Our second lesson for today is quadratic word problems. So first example, a ball is thrown into the air. The path of the ball is represented by the following equation. H, which is your height, equals -16 times t squared. T is our time in seconds, plus 96t plus 200. Letter A asks us to find the height of the ball after 1 second. So we're trying to find H and we're given T. So to find H, if you're given T, you're just going to plug in 1 for T. So -16 times T squared, so I'm putting 1 squared there, plus 96 times 1, plus 200. So I would type all that in my calculator, make sure that you use your parentheses, don't forget that negative. You should end up with H equals 280. If your height is 280, we're gonna assume that it's feet. So after 1 second, the height of the ball is 280 feet. Part B says, what is the maximum height reached by the ball? And then I give you a hint. This is a two-step problem. First, you need to find the time that it takes by finding or by using x equals -b divided by 2a, and then do another plug and chug. So really, I'm asking you to find this ordered pair right here, x comma y. X is the time it takes to get to the max height, and then this is your height. And again, that's your vertex, so it's going to be the maximum height you have. So x equals -b divided by 2a. I'm going back to the original. The opposite of 96 plus u is -96 divided by 2 times a, which is -16. When I simplify this, -96 divided by 2 times -16 gives me 3. So at 3 seconds, the ball is at the maximum height. To find the actual max height, I have to plug in to the original equation. The height's going to equal -16 times 3 squared plus 96 times 3 plus 200. And again, I'm just typing that all into my calculator. So we have a max height of 344 feet. So 344 feet would be the maximum height reached by the ball. If we continue this problem on the next slide, we're using that same equation, and part C asks us how long it would take the ball to be at 88 feet. And I've given you instructions that you're going to set the equation equal to 88 because 88 is the height that we're concerned about. Then we want to move everything to one side. I'm going to subtract 88 from both sides to get this 0. Now I could look at this and think, hey, I want to put this into my asterisk, but I don't quite want to do that yet because in my asterisk I have to multiply a times c, which means I would have to take -16 times 120 or 112. Oh, I just lost my. Which gives us a number or a value that's over 1,700. Sorry, I lost my work. So we want to find the greatest common factor at this point. So if I find the greatest common factor, I'm just going to tell you on this and on your test, it's going to be whatever number's in front of t squared. I actually think on your test it happens to be -16. So I'm going to divide every single term by -16. So that's going to give me a new equation. 0 equals t squared minus 6t minus 7. So now I have another quadratic. This is much easier to plug into my asterisks to factor. So now I'm going to take this and I'm going to plug it into my asterisks to factor. So in my asterisks, I have 1, 1, top left, top right, -6 in the bottom middle, and -7 in the top middle. Two numbers that multiply to give me -7, but add to give me -6, -7 and +1. So now I have factors of t minus 7 and t plus 1, still equal to 0. Set them both equal to 0, t minus 7 equals 0, t minus 9 plus 1 equals 0. Solve for t, which gives me t equals 7 and t equals -1. Remember, t represents your time in seconds. If t represents my time in seconds, is it possible for you to have a time of 7 seconds? Yeah. It's not possible, however, to have a time of -1 second. So that answer is what we call extraneous. We didn't do anything mathematically wrong. It just doesn't make sense in context of the problem to say, hey, it took -1 second for the ball to reach 88 feet. The next one, we have a diver jumping off a diving board. The path of this diver is represented by this equation. Again, h is the height, t is the time. For part A, we're asked the height of the diver after 2 seconds. That's just our plug and chug. The height equals, we're going to take -16 times 2 squared plus 16 times 2 plus 192. So we just went to the original equation, taken out the t's because we were told the time. That gives me a height of 160. Again, we're assuming it's feet. So at 2 seconds, the diver is at 160 feet. For part B, it wants to know how long it takes the diver to reach the maximum height. That's asking you to find the x value of your vertex. That's our -b divided by 2a. That's the time it takes to reach the maximum. So we're finding this distance here. So to do that, we're going to take -b divided by 2a. So -16 divided by 2 times -16, which is 1/2. For this, I'm going to go ahead and convert that to a decimal because for the next step, I've got to plug that back in. So it takes 1/2 a second for the diver to get to his maximum height. He's jumping off a diving board, so he's only increasing his height for 1/2 a second, and then he starts coming back down. So part C, we know the maximum height reached by the diver. We're just going to plug in 0.05 or 1/2 if you choose to do it that way. So I'm cheating. So there's what I would type into my calculator. Again, I've just taken out the t's, plugged in 0.5s, and that tells me that the max height is 196 feet. All right, one last one, letter D. Again, we're using the same diver and diving board scenario, but this time we've been asked to figure out how long it takes the diver to reach the water. If the diver's reaching the water, that just means that his height, yep. So for this, we're wanting to figure out when his height is 0. His height's 0 when he hits the water. So we're plugging in 0 for h. Negative 16t squared plus 16t plus 192. For this scenario, you don't have to move anything. It's already in standard form. But again, I want to factor out the greatest common factor. In this case, I just want to divide by negative 16. Again, I want to divide all the terms by negative 16, including the left side, which is 0. That makes your life easier, gives you smaller numbers to deal with. So 0 equals t squared minus t minus 12, which is much easier to factor. In this case, you have 1 at the top left and top right, negative 1 in the bottom middle, and negative 12 in the top middle. So I'm looking for two numbers that multiply to give me negative 12, but add to give me negative 1, negative 4, and positive 3. So then I'm looking at my two fractions on the left and right. Since 1's on top, I know I can't reduce. So that gives me my factors, t minus 4 and t plus 3 still equals 0. It doesn't matter if you write your equal 0 on the left side or the right side, as long as you have it. So then t minus 4 must equal 0, or t minus plus 3 equals 0. When I solve for t, I get t equals 4 seconds and t equals negative 3 seconds. And again, since this is a word problem, negative 3 seconds doesn't make sense. To tell me that the diver is at the water at negative 3 seconds when we know he's standing up on top of the diving board just doesn't make any sense. So then we figure out that the time is 4 seconds. It takes 4 seconds for this diver to reach the water. That means he's in the air for a total of 4 seconds.